We're going to talk about graphing sine and cosine waves with the change in period, which actually means the frequency. Basically, a normal period or complete wave of a sine or cosine function is 2 pi radians. However, the period will change to the constant b in the general equation. So here's our constant b in the general equation. Okay? So what we're going to do is I'm going to show you an example of what you do when you're using the table, and then we're going to go to the graphs. So we're going to graph y equals sine of 2x. So my b is 2 here. We're also going to graph y equals cosine of 1/2 x. So that's going to show you the difference. For sine, I'm using my normal quadrantals first. I'm going to put in my range values that you should know by now. 1, 0, 0, 1, 0, -1, 0. And what I'm going to do with this x here is divide this value by 2. So when I divide this by 2, I still get 0 here. This is going to be pi over 4, pi over 2, 3 pi over 4, and pi. What this means is the sine is going to make a complete wave or rotation type thing, frequency. Instead of making complete wave in 2 pi radians, it's going to make a complete wave in just pi radians or 180 degrees. And the formula is right here. If you want to know the period, this is our b is 2. So we're going to say the period equals 2 pi over 2, which equals pi. You can also see, and I'm going to draw a little line here to separate these two, that basically this is 2x, and this is your x now. So to get my x, I had to divide everything by 2. Now for cosine, before we move on, I'm going to go ahead and put my range values in, which are 1, 0, -1, 0, 1. And what I'm going to do with this is 1/2, we're going to let this equal 1/2 x. So I'm going to, for my x here, I'm going to have to multiply everything by 2. I'm going to get 0, pi, 2 pi, 3 pi, and 4 pi. That means it's going to make a complete rotation in 4 pi radians. Or we could say the period equals 2 pi over 1/2, which is the period equals 4 pi. So I think if we look at sine of 2x first, we can get a better idea of what's going on, and then we'll come back to the tables. So I took the liberty of drawing the parent function of sine. So this is y equals sine of x. Now what we want to draw is y equals sine of 2x. I'm going to go back to my table, and the values I'm going to use are these two. I'm going to use this as my domain, and this is my range. And when I do that, I have these values here that I haven't included. So this would be pi over 4, 3 pi over 4. And when I draw it, I'm going to do my little dot thing. So dot, 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 dot. And then I'm going to draw it this way. So it made a complete wave. Made a complete wave in pi radians. I'm going to go ahead and continue, and I'm not going to really fill this in. We're going to do that in a later video when we combine everything. And I'm just going to kind of complete this over here. So it actually made 2 complete waves between 0 and 2 pi. this is where the 2 comes in. It makes 2 complete waves. And that's why we had to divide our initial quadrantals that we're used to using by 2 so we could get this result. And I can continue on. I'm just going to divide all of these by 2 here, or divide them in half, and then do my little dots. Dot, 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 and just kind of connect the dots. And I have 2 waves on the negative side. So that is sine y equals sine of 2x compared to the parent function y equals sine of x. Now cosine of x I haven't drawn yet. I went ahead and drew the domain values for y equals cosine of 1/2 x that I got from the first slide. So I'm going to go ahead and draw y equals cosine of x. You already know it goes from 0 to 2 pi, so we know this is pi over 2, and this is 3 pi over 2. So it would be dot, 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 okay, and then make it curvy. So there is your normal y equals cosine of x. However, if we graph y equals 1/2 cosine of x, we are changing it. The whole wave completes in 4 pi radians. So basically the dots go like this. We're not even using these half ones. So dot at pi goes to 1, and then at 2 pi it goes back to 0, 3 pi it goes back to -1, and 4 pi it goes back here. So I'm going to draw this. So basically it doesn't finish its whole wave until we get to 4 pi radians. And as you can see, this 1/2 means we only could do a half right here. 1/2 from here to here of the cosine graph or the wave to 2 pi. We didn't even complete it. From 0 to 2 pi, because this is 2 pi here, we only could complete half the wave. So that's where that's coming in. Now I'm going to go ahead and finish this. I'm going to go and half this and go ahead and draw the cosine. So I'm going to go down, down, up, down. All right. Dot, 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 dot. And then I'm going to go ahead and draw the cosine on the negative. So that would be dot, go back up to 1, and back down. And the same thing applies to this side. It only completed half of the way between 0 and -2 pi. And I'm going to go back to the original table and look at what we did. We had to take half of our original quadrantal values and take half of them to get our new values to graph. Okay? The next video is going to be about phase shift, which is just horizontal shifting.